Okay, part 2 of exponential function applications. Say that 5 times real fast. Exponential applications. Half-life decay. The half-life is the amount of time, very important, it takes for half of the atoms in a sample to decay. So, a chemical substance will decay by half in 3 hours. So the half-life is 3 hours. That's how long it takes for the chemical substance to decay by half. Complete the following table for 200-gram sample. So in 3 hours, how much is remaining? Well, we know the half-life is 3 hours, so half of 200 is, yeah, 100. Sometimes the hand follows the mouth rather than the brain. Anyway, and then of course 3 hours later, we're going to do half again. And 3 hours later, half again. So our exponent, well, let's write this out here. Here's our formula down here, our initial amount. So we're going to have an initial amount of 200. It's a half-life, so the base is automatically 1/2 because it's halving. We might also look at that as 1 minus 0.5 because the rate is 50%. Okay, so we're losing 50% each time. And then time, and we put the half-life, we divide the time by the half-life. So in this case, the half-life is 3. And this is going to give us our new amount. So for example, when hours is 0, 0 divided by 3 is 0. 1/2 to the 0 power is 1. 1 times 200 is 200. Okay, plugging 3 in, 3 divided by 3 is 1. 1/2 to the first power is 1/2. 1/2 times 200 is 100. Plug 6 in, 6 divided by 3 is 2. 1/2 squared is 1/4. 1/4 of 200 is 50, and so on. And you can see time divided by k, where k is your half-life. Again, a sub 0 is your initial amount, just like before. Everything else is very similar. Note that t and k must have the same units of time. So if time is in weeks, then our half-life also needs to be in weeks. So B, how much will be left after 10 hours? Well, thankfully, our time is in hours, and our half-life is also in hours. So we'll have 200 times 1/2, plugging 10 in for t, 10 over 3, and (200) times 1/2 raised to the 10 divided by 3 power. So we'll have 19.8 grams, approximately 19.8 grams. Okay, so that's half-life. Let's continue on here. Next thing we're going to look at is compound interest, which is also an exponential function. It says $4,000 is invested. So that means we're starting off with our initial amount of $4,000. It's invested at an annual rate of 6%, so we know we're going to be growing. It's compounded quarterly. Quarterly means 4 times a year. 4 times a year. And compounded means it's going to be calculated. So your interest or your rate, the amount of money you're going to get, your interest, is going to be tacked on to your $4,000 4 times a year. Okay? Complete the table below if no withdrawals are made. So the formula for compound interest is at the very bottom, so let's take a look at it. Compound interest, we have P, which is very similar to A sub 0. It stands for the principal, or aka the initial investment, okay, our initial amount. How much did we start with? R is our interest rate. N is the number of times compounded per year, and T is the number of years. So it's a very simple formula to use. You just need to plug in the numbers in the correct locations. So if we're going 3 months, we're going to, that would be our first quarter, because if we take 12 months in a year, divide that by 4, we get 3. So every 3 months, we're getting some money added on to our 4,000. So 4,000, okay, following, that's our principal. And then we have 1 plus our rate. I'm following this down here, so look down here. Our rate, which is 6%. Remember to change it to a decimal. Remember, you change a percent to a decimal by either dividing it by 100 or moving the decimal place over 2 places. Let's see, divided by N, which is the number of times compounded per year, which is 4. It's quarterly. And raised to N times T. So again, 4 times T. So since the time is 1 year, remember, it's very important. T is in years. So 1 whole year hasn't passed. So instead of putting 4 times 1, we've only done 1/4 of a year. So instead of putting 1 year here, we're going to need to just do 1/4. We're only doing the first quarter. So 4 times 1/4, which is 1. So plugging this in, we have 4,000 times 1 plus, and then we have and we're going to raise that to the first power, because 4 times 1/4 is 1. So we have this amount. Alright, put the number in incorrectly, so I had to redo it. So the correct amount would be $4,060. Next quarter, same procedure. Started with 4,000, 1 plus 0.06 over the number of times compounded, and this time it's going to be raised to the 4 times 2/4, because now we're in the second quarter, 2 out of 4, which is going to give us $4,120.90. And then the third quarter, so 4,000, 4 times 3/4, and that's going to give us $4,182. Now here, we're in years. So here, we just need to use the formula. Plug 1 in for t. Four times 1. And we're going to be up to $4,245.45. Save that one for you. Write a formula for the amount in the account after t years. Well, we have the formula right here. We got 4,000, our initial value, our principal, times 1 plus our rate, divided by the number of times compounded in a year. So 4 raised to the 4, that's the number of times compounded yearly, times t. And remember, t is in years. This time it has to be in years. Okay, so how much will be in the account after 5 years? So 5 goes in for t. How much would be in the account after 5 years if the interest is compounded monthly? Monthly, so how many times is it compounded in a year? So 12. So we're going to need to change this formula. What number is going to change for C? That's right, the 4's will change to 12's. It says find the principal needed to have $5,000 after 10 years at 6.5% compounded monthly. So for this one, we're looking for the principal. And they give us the ending amount. So we have to put the ending amount here because this is the result, the amount that we end up with. Okay, if you look down here, it tells you A of T is the amount in the account after 10 years. So that's what we end up with. So we know we're going to end up with $5,000. Okay, and we're looking for P. How much money did we start off with? Okay, filling in the rest of it's compounded monthly. The rate is 0.065. And we're going to have 12 times 10, the number of years. So now we want to find P. Very easy to do. Use algebras and solve that. Okay, I think we're going to end right there for tonight. Hope you guys are having a good evening. See you in class tomorrow.